Hello judges, greetings from India. I'm Sanjana Golaya and I'm a final year engineering student. For this hackathon, I have decided to implement a paraphrasing model which leverages some natural language processing techniques and is built by fine-tuning the Facebook BART large model, which is a transformer sequence-to-sequence model with a bidirectional encoder and an auto-regressive decoder. To simplify this a little, let me just share the deck that I have put together.
Right. So within the domain of natural language processing, we mainly have two kinds of models. Firstly, we have an MLM model which uses only an encoder and is more suited for tasks such as classification. Let's say in the example of a sentiment analysis. An example of this would be the famous BERT model by Google. On the other hand, we also have auto-regressive models which only use decoders and are more suited for tasks such as text generation. An example of this could be the GPT-2 model. Now, BART makes the best of both worlds as it has both an encoder and a decoder, and it's suited for tasks such as summarization, abstractive question answering, paraphrasing, among more. For the purpose of training my model, I use three datasets, one by Quora, one by Google, and the last one by Microsoft. Let me just quickly show you what all of these entail. As you can see, in all of the three data sets, we have columns such as an ID, a first sentence, a second sentence, and lastly, we have a label indicating whether the two sentences have semantic equivalence. An example from the Quora dataset is given over here. I've included the links to all these three datasets in my GitHub repository in the readme.txt file. Quickly outlining the methodology that I've followed for this project. Firstly, the text has been cleaned and pre-processed, and the code for this can be found in the utils.py file in my GitHub repository. Next, the Facebook BART large model has been fine-tuned by setting arguments and hyperparameters, and lastly, the model has been trained on the Amazon EC2 DL1 instance. For the instance, the latest Habana deep learning base army has been used with the TensorFlow framework image, and all of the 8 Gaudi accelerators have been used using the Horowitz strategy, which I'll be showing in the demo up next. But before that, some of the use cases. Firstly, we have automated FAQs. For example, if a person has asked a question and a similar question has already been answered before, then the user can be automatically guided to that particular question. Next, we have better plagiarism check systems, which not only check for word-to-word match in sentences, but also the semantic equivalence. And the future scope of this project lies in integration with various softwares through APIs. Now, moving on to the demo. After verifying that all of the 8 Gaudi accelerators are configured correctly, we then launch a Docker container with all of the Habana libraries, and we also pass in the TensorFlow image provided by Habana. Next, we git clone our repository. Next, we cd into the repository where our Python script is available and export the Python path. Next, I will quickly install some additional packages required. These are simple transformers and torch vision. Finally, run our Python script and pass on some additional parameters like the Lars optimizer, and we use the Horowitz strategy for distributed training across all of the 8 accelerators. And as we can see, the training has finally begun. In each of the epochs, we will be able to see the current running loss, and there we go. Some of the results are displayed over here, and the others can be found by simply running the AWS BART paraphraser file in my GitHub repository. Thank you.